Okay, so I'm just going to kind of walk through quickly the lab. You'll have to pause as you go through because I'm not going to work out every step. But if you want to kind of stay with me, then just kind of pause when you get to a point where you need to write some stuff down. And that way you don't get behind where I'm talking about in the lab. Okay, so this is a lab that we actually would normally do in class where you would make a solution. So it's kind of turned into, like a paper lab. So here, the first thing is just the steps. Okay, so what are the first things that we do? So we have to make sure we mass out our solute, right? What we're wanting to dissolve. And then we use this special flask called a volumetric flask. The main difference between a volumetric flask and lots of other glassware that we've used before is the volumetric flask only has one line and it only measures one specific volume. For example, this is a 500 milliliter flask. Okay, so the only reason I would use this flask is to make a solution or to measure out 500 milliliters. The only line on this flask is right here. So when I get remember we measure using a meniscus. So when my meniscus reaches that line, okay, that means that I have 500 milliliters in this flask. I can't fill it up halfway and say, oh, I have 250. Okay, it doesn't work like that. So what you're going to do, you're going to add a little bit of solute, however much you needed, right? However much you calculated. You're going to add that to your flask down here on the bottom, and you're going to add just a little bit of water. So you can see they added just a little bit of water down here, and then you're going to kind of swirl it up and mix it. Okay, so that step 3 is swirling it up. What I want to do is it's very difficult to dissolve if I filled my solution up all the way to the mark because I can't really swirl it very well. So if I start swirling it when I've only added just a little bit of water, it'll kind of help it start to dissolve. And then once I get it all the way dissolved, if I need to add a little bit more water, I can. See, like they've added a little bit more here. Okay, and they're still swirling. Once it's all the way dissolved, then I can fill up the last little bit of my water to my flask. Okay, when that happens, right, it says you're going to stopper the flask. That means we put a little rubber stopper in the top, and then we're just going to kind of turn it upside down a couple times just to make sure it's good and mixed. Okay, mixed all together. So on your lab sheet, right, you're going to click this little link here, and it kind of will explain or show you kind of the video of how we use the flask. That way you can kind of, it'll make more sense as we go through the simulation. Okay, so for our lab today, we're trying to make a 0.5 molar copper chloride solution. Okay, and we're using a 50 milliliter volumetric flask. So if I have my molarity, which I do, right, I can figure out how many moles of my copper chloride I need to make. Okay, so everywhere where there's a little number sign, you're going to actually click it and type in the actual value that we're trying to plug in. So for example, my molarity, I would click delete this number sign and I would type in 0.05. Okay, same thing with my number sign for liters. Just remember, right, if we're 50 milliliters, I have to turn it into liters. I have to move my decimal 3 places over. Okay, so then that also comes out to be 0.05. Okay, and so I'm looking for moles, right? So I have to multiply. So I have to multiply each side by 0.05 to get rid of it, right? To get my number of moles. So then I'm going to type my answer in right here. Okay. So we have our number of moles, right? But we can't actually measure moles. We don't have any kind of tool or instrument that can measure the number of moles. It can only measure the number of grams. So we have to convert our number of moles into grams. Okay, so we're basically using this, right? We have moles, And we know that 1 mole is a certain number of grams, and I get that number from the periodic table. So that's what this is helping you find, is this number of grams right here. So copper chloride is actually what we call a hydrate. Basically, it just means that there's 2 little bitty water molecules trapped inside this crystal, okay? So when we're calculating our molar mass, we want to make sure we calculate those 2 water molecules as well. So you have some steps here. You're just looking at your periodic table, and you're just adding up the mass, right, on your periodic table, okay? And then so you'll get a total here once you add up the copper chloride and the 2 waters, okay? So now, all right, we have our moles, right? This is from part A, so I'm going to scroll back up to the top, what I got there. So I'm going to actually type that in here where my number sign is, right? And then I'm going to actually type in this, right, is this right here, okay? And that's going to give me some kind of answer here. Okay, this is going to tell me how many grams. So on my balance, I'm actually going to weigh out this number of grams that I get here. Okay, so here's a little picture of our materials. All right, we have our flask, we have a little stopper, we have our glass bottle, we have a pipette, or our water, sorry, our pipette, and we have our balance, and then here we have our little copper chloride solid. Okay, it looks like a little blue crystal salt. It's pretty. So now we have all of our materials. Okay, so I want you to go back to the beginning in that box where we talked about kind of the steps to make our solution. Okay, and I want you to type out just a quick little procedure. Okay, so we're just going to make a list of steps that we'll need to do. It's a good idea to actually use numbers from our calculations. Okay, so tell me, how many grams are you going to weigh out, right, and put into the flask. Make sure you pay attention to, how are you going to get that to dissolve? Are you going to fill it up all the way to the top first, or are you going to do something before that? Okay, so just kind of scroll up to look at the top, look at the steps. Okay. So this part is kind of the second part that we would do. Okay, so after we've made our first solution, I would actually have you make a dilution. Okay, so remember, that means I'm going to add a certain amount of water to it and make it less concentrated. So we have this formula here that we can use, right? We have our beginning and then we have our end. Okay, so what we're doing, okay, we've been given a new solution. Okay, so in this case, right, I'm going to give you a new solution just so we kind of all start off with the same values. You have a 100 milliliter flask, okay? We have our 0.05 molar solution, okay? So this is the solution that you've made, but I'm giving you some more materials, another flask, right? So you can kind of start with your new, and we're going to try to dilute it to 0.03, okay? So let's see what we're going to plug into our formula, okay? So M1, V1, right? Again, these number signs is where you can plug in your values. This is my start. So what am I starting with, right? What is in your flask, right? How big was your flask? Okay. So we know that we're going to have some kind of volume. We're going to need some amount from your flask. We just don't know how much we're going to need. Okay, so this is what we're looking for. We're looking for this V1. Okay, so my starting value, I know, is what they told me I'm starting with, 0.05. Okay, remember, I'm looking for V1. That's what it tells me right here. My second molarity, right, I'm trying to dilute. I'm trying to make this. So that's 0.03. Okay, and then I've been given my final volume, which is 100 milliliters. Okay, so I'm trying to figure out how much of my first solution that you just made, do I need to make this solution? Okay, so you should have some kind of answer right here. And you have some questions. Okay, so these are more just kind of looking at this picture, kind of using a lot of the information that we talked about even while we were actually in school. So see what you can do by yourself on these questions. Okay, and just think about what happens to these particles in a solution. So you kind of have this picture here to kind of help you with that. Okay, so hopefully this made a little bit more sense if you walk through. If you have any questions about it, feel free to email me.